And thanks for everyone. And this is Jian from NVIDIA. And I'm glad to be here to share some of our experience of using AI agent for our production AI systems. And let me jump into the main topic. And firstly, there's no doubt agent become a very important and popular technique. And also being a technique, it has its own temper and styles. And to make sure we can use it efficiently, we need to make sure we can leverage advantage and the disadvantage as well. And also there can be very big difference between using AI to build some one-off showcase compared with building a production usage. And for production scenarios, we care a lot about things like maintainability and controllability and completeness, and which can be different from building a one-off demo. And this can impose additional requirement and constraint for us when we try to use agent. And here I will provide some examples to try to illustrate our experience of using agent for our production AI system. And there are around 3 examples about inference, one about training. And for inference, we are choosing the TensorRT, and which is NVIDIA-powered large language model inference frameworks. And this has been used by a lot of customers, and also it has been used to support a bunch of key benchmark submissions like MPerf and semi-analysis and artificial analysis. So this is indeed a production-grade software, and this can impose additional challenge for us to use agent. And the first example is to build an agent-based bug fixing Autobot to make sure we can release our burden from the daily bug fixing duties. And the workflow is relatively straightforward. On the left part, we have the agent flow, starting from the bug analysis, then do the bug reproducing. After we are confident that the bug is reproducible, we will enter into the bug fix stage by the agent. Then the fix will go through the review phase, still by the agent. And after the agent feels comfortable with the code fix, we will enter into the verification phase, still by agent. After verification is done, we can mark the agent fix phase as done. Then we enter into the human phase. And the human here need to review the code carefully to make sure the bug fix is not a reward hacking, it's not a hacky, and it can be complete enough. And also sometimes the human need to provide feedbacks to the agent workflow to make sure the agent can continue iteration until it finally converges. And here is a dashboard about the bug fix agent. And on the top part, we can see that among the 800 bugs, there are around 313 bugs, which already have the fix from the agent. And if we zoom in further into the bottom, we can see that among the 313 bug fix from agent, only 73 of them have been accepted and landed to our main branch. And there are more than 100 fixes which can be rejected by human because we feel the fix is not complete enough, or maybe too reward hacking, too superficial, it's not great. This indeed is a very concrete example indicating the gap between production requirement and what agent can do. And this is also the area we are keeping improving to increase the ratio of the bug fix, which can be finally landed to our main branch. And another example is about using agent to try to increase our velocity of supporting new model in TensorRT. And there are new models coming in almost every month, sometimes every week. And we want to make sure we can support a new model quickly. And so we built an agent-based modeling tool to try to increase velocity. On the left part is a basic user workflow. We provide a user command line called model dash and bring up, and the user just need to specify their model definition, their criteria into the task YAML file, then can fed into the agent flow and can run through the agent process. And to make sure human can do the intervention properly, and human can interrupt the agent execution process with providing his feedback, and then can retrigger the execution to make sure the agent can be steered towards the right direction we want. And on the right part, we can have a zoom-in understanding about the basic agent flow. This is also a very typical multi-agent workflow. We have the plan phase, we have the implementation phase. For the plan phase, we have the plan generator, we also have the plan reviewer. And for the implementation phase, we have the coder and reviewer and QA. And we on purpose try to divide the responsibility into several sub-agents to make sure each agent can be very focused, they can use their content effectively, and also they can share the common information through the intermediate files. They can work together as a team. And here's an example. And here we are using the Gamma 4 from Google as an example to demonstrate the effectiveness of the model agent. And in the x-axis is the iteration number from 0 to 175. And on the y-axis is the QA score, and the higher the better. And we can see that starting from the planner, it will trigger execution. Then the coder will have a multiple iteration with a reviewer. Finally, reviewer thinks it's OK. It can pass the board to the QA to do the evaluation. Then QA can send the result back to the coder. Coder will do it again and again, and there can be intense interaction between the coder, reviewer, and the QA. Finally, it can be converged. And here's another example on top of that one. And in this figure, we just add another plan reviewer phase, which we found is very effective for us to improve our token efficiency. And by introducing the additional plan reviewer, we found we can converge with the same quality with just 35 iterations, which can save our tokens. And the next example is also for Gemma 4 model. And when we finish the new model bring up based on agent, we want to use agent to do performance improvement. And here we just start from a low performance baseline with doing 3 additional iterations. For the second and the third iterations, we do have a bunch of optimization finished. And for the fourth iteration, it finally become converged. So we just stop the optimization process. And for the second and the third iteration, we can notice that the agent will create some cookbook. The cookbook consists of the optimization experience accumulated by the team during the past. We just prepare them in a structured way, so agent can use them. We can see that in the second iteration, the agent will create some cookbook about host performance optimization, then apply to the final optimization. In the third iteration, the agent will create some cookbook about CUDA graph, then finally apply to the optimization. And also we can notice that there are a bunch of optimization and have been done, but finally not accepted because due to that the performance again is very marginal. That's decided by the agent workflow. And next one is about training. And for training, although it has something in common with the inference, also there are some different characteristics. So we are still using different workflow to optimize the performance for inference and training respectively. And for training, initially we started from building a deep agent-based agent workflow. Eventually, we moved towards building a very lightweight harness on top of the general coding agent because we found the evolution of the general coding agent actually can take over something we have done before based on deep agent. So we want to make sure our agent flow can be lightweight and adaptive, so we can leverage the advances of the general coding agent and foundation model. And the basic architecture of the training perf agent is very similar like before, and there are some additional things we added into the training agent flow, such as the kernel arena, in which we try to reuse our history kernels to make it easier for us to generate future kernels. And also we have a learning feedback loop in which the agent can do the trace analysis about the past execution, and the human can do the review, then we can just feed into the agent flow to iterate the training agent. Also, we have built an evaluation toolkit, which can be used to evaluate the effectiveness of agent workflow. So when we add a new skill, add some new sub-agent, we can be relatively certain that it will not introduce too much regressions. But it's not very ideal. We are still trying to figure out what is the best way to defend the agent system evolution. And here is an example by using the Flux model, which is a vision transform model, to demonstrate the effectiveness of the training perf agent. And this model actually has a very good performance baseline based on human observation. And starting from the beginning, it has tried more than 120 experiments, and some of them will be OM, and some of them can run through but will be rejected, and some will be capped. Finally, 20 experiments will be capped, with totally bringing around 20% performance improvement, which is a very decent number considering we are using a very strong baseline. And finally, let me make a conclusion about some lessons, pitfalls, and limits we learned. And firstly, and the nature of agent intelligence is very different from human intelligence. It's by nature is a probabilistic-based process. So when we design anything, we should take that into consideration to make sure we can use it as an advantage and avoid its disadvantage. And the second thing is that when we are trying to build agent, we should make sure we are not building a very heavy harness. Rather, we should try to make sure the customized agent workflow should be as lightweight as possible, so we can be able to leverage the future evolution of the general coding agent and the foundation model. And also, there are some interesting trade-offs we should consider. For example, and how to make sure we can balance between the fully autonomous agent plus versus the human plus the agent. Yeah, and on the one hand, we want to make sure we can automate everything as much as possible. On the other hand, we found that it's not rare when we try to combine human plus agent, it can be much more efficient in terms of token efficiency and iteration speed. The second thing is that for production, usually we want to centralize our logic to make sure they can be used by different places. But we found it's interesting to notice, due to that agent can write code so fast, so human plus local custom agent can sometimes work more efficiently than the centralized agent. So we should make sure we are aware there isn't a single silver bullet. And lastly is that we should make sure we balance between customized agent plus the lightweight harness to make sure we can quickly evolve with the new advantage of the foundation model and the general code agent. Yeah, and with that, I can conclude my sharing. Thank you.